Good evening and welcome to tonight's class. Currently we are in section 6, Python for data science. So we'll be looking at some libraries for data analysis with Python. Like I said, if you are already learning these libraries, you are already on a path to data science. So we'll look at Pandas tonight. Pandas love data science. Pandas is fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. Pandas is a Python library. Pandas is used to analyze data. I say to install Pandas, say pip install Pandas for the very first time. Then the next thing is you import Pandas. How do you import Pandas? Import Pandas as PD. This PD now serves as alias. So that's how to import Pandas. You import NumPy. We are not doing NumPy now. You want to use NumPy, you can import NumPy. But normally, once you are able to learn all the libraries, if you are working on a file, you will just import Pandas, NumPy, Matplotlib, the three things at once, because you might likely use the three. You might be using Matplotlib as you are working. You are using Matplotlib to show what you are doing in, to show the charts of what you are doing. So just import the three things at once. That's when you are done learning the three packages. But as you are starting with Pandas, just import Pandas for the start. As you are starting with Pandas, so it's okay. So how to import data to Pandas, just like SQL? How do you import you guys learn how to import data to SQL? It was very tough, right? It was tough. Let's say, for example, one thing to do is to upload that file to your Jupyter. Ensure you upload the file to Jupyter. You go to upload, you check the location of your file and upload it to Jupyter. You can create a new folder to save things. So when you open the folder, like now I'm on Python codes folder. So if I go outside, this is, so all my Python codes, they are here. So, and I have my files uploaded to this place. I have even the films.csv. So see some files that I have. So this is a one I open here. But for practice says, let's do something. I'm going to import Pandas. So right now I'm going to import a file to Pandas. It's very easy. Imagine this line of code is enough to import a file to Pandas. This line of code, unlike what that thing we're solving during SQL, just this line of code. This df stands for data frame. Data frame equals to pd dot read csv. The file is a csv file, then to bracket the name of the file. As simple as this. I will change this one to, let's import another file. I think I have that films.csv here, right? Films.csv. I don't know. Let me see if I spell it correctly. So I will now say df so that I can see the file. Okay, look at it. I've imported it. So that's simple as that. You have imported file, your data set to Pandas. As simple as that. Look at Python is very powerful. So as simple as this. What you were using command line to do with SQL, as simple as this, the job is done. So what next? To see the file you have imported, just click on df. It will show you the file. So another thing is type df. You want to check the type of df is what? Pandas. So another thing is we have df.head, then into bracket. If I enter this, by default it's going to return the top 5 rows. By default it will return the top 5 rows, so you can determine the rows. So you can say return the top 10. It will return the top 10 rows for me, so use that. Another thing is df.tail. df.head returns from the top, while df.tails return from the bottom. You can see it return the top 5 from the bottom for me. If I put like 10 now, it will return the first 10 from the bottom. Now df.info, it just give you information about the file and the data set you just imported. You can see it's telling me it has total 10 columns. You can see their columns. You can see whether they have none and null. You can see the objects, the object type, whether integer, float, as the case may be. Then we have df.describe. It will just describe. If you are into statistics, you should be able to understand this better. So to just describe the file. Then df.columns. df.columns to just return all the columns. These are the columns I have in this file. df.t. df.t. This is transpose. You guys should know what transpose is. Transpose is just like, in transpose now the columns become rows and the rows becomes columns. So that's what is happening here in transpose. So probably in future you might have a need for it, so you can do that. We also have df.sort. If I say df.sort values, in this data, let me look at the values. I want to sort from the year. I want to sort from the year. I will sort year. So it's going to start from the. It's going to start from the. Just like you sort, like you use your SQL, where you sort from the year ascending, 19, 15, 16, like that, and it will go down. So that is what df.sort values does. Just like normally in your SQL, just to sort something ascending. So that's what it does. So let's look at this one. If I use this df.sort year, if I run this, I think we have an error here. What's wrong with the year? I don't want to believe that. Huh? It seems funny. Why? Because I started the year with capital letter. So we say df dot sort values here. We now say ascending false. This is how to sort from the descending order. If you use df dot sort values, then you put the column. We are sorting in respect to the year column. So if you put only the column, by default, it will sort it ascending. Just like in SQL, when you write and when you are doing sorting, if you don't indicate, it's just using ascending until you indicate before you now use descending. So if you now say ascending false, meaning that you do it descending to start from 2023. Like I said, normally it will bring the top 5. This one means that there are other things there. Then it will now return the bottom 5. So what again? So you can access a column this way. You can access a column this way. Let's say the general. You can access a column this way. You can see in general we have drama, action, animation, and action. So you can access a column by doing df square bracket. You put the column name. You can also access it like this: df dot general. It will return it. But if you are having something like this, df dot first name, it won't work. So if you have a column that has space, so you use the first one, you put it inside and square bracket. So that is it. But with just one line of write up, you can use df dot, then you put the column name. So I want to do something. I can add a new column. If I say df dot, let's say I want to add a column known as random column. You can give it any name, then equals to good day. Let's say I want to add a column known as let's say feedback. After watching the movies, I have a feedback. I will now say very good. So I will add a column known as feedback. Then I will just populate it with values known as very good. If I strike enter, if I check my df, you can see the column has been added, feedback, populated it with very good. So that is how to do that. Another thing is, okay, how to access rows. You can access, like I said, in Pandas, just like what we have here. When you view your data that you just imported, this data has 9,849 rows. So you cannot just return everything together. It will just return the first top 5 and now put dash dash here. This dash dash means that there are a lot of things, like it just truncates the data, understand, and returns top 10 rows for you. So now what if you want to see the 20 to 25 rows? So you just put it like this. This is how to access it. If I strike, you see it's returning the 20. This is the 21, 22, 23, 24, 25 rows for me, returning from the 20 index to the 25 index for me. Remember, in Pandas you start counting from 0, so meaning that this is my 20 index, 21, 22, 23, my 25th index. So like now, even if I want to access let's say 8,000 to 8,900 rows. I think you have some. So that is how you can access data. That's how you can access. If there's a row you want to access, so that's how you can go about it. So we have another one, something like this. df square bracket df dot age greater than 50. This is just like saying select everything from table name where age greater than 50 in SQL. That is just like saying select everything from the table name where age greater than 50 in SQL. This is just like this. So now I will write something with this. I will say select year so let me put greater than 2000. Select. I also want to see for the values when the year is greater than 2000. If I strike enter, you can see now if you look at the year column, you can see that you will not see anything that is below 2000. You see 2000 and above. This means that where year is greater than or equals to 2000. When you see something like this, greater than or equals to, means that the year is greater than or equals to 2000. It can either be 2000 or greater than 2000. So that's what you are going to see here. That's what you are going to see here. Just like there's something we call, you guys learn how to create views, right? In SQL, you learn how to create views. That's what is happening here. How to create views. That's what is happening here. I can give this a new name. That particular you know that in SQL, when you are creating views, after your condition, that table that it just returns, you can create a view out of that table. You can create, that means you can create a table out of that. So let's assume you want to create a table out of this. I can call it can give it anything like top here. So I'm creating another table with this condition that all the, after I've been able to filter everything that is less than 2000, the year 2000 out. So I want to create a table with all the movies that is 2000 and above. So this is just like, this is my new table name. We've been using df, just like assume this is my new table name. So if I strike this, so let's say learn top, yeah, you can see now the data was 9849 rows, right? After creating a new table with this condition, the data has been reduced to 6511. That means we have 6511 movies that is above, that is 20, that was produced in the year 2000 and above. So we have 6511 movies that was produced in the year 2000 and above. So this is what that means. If you check learn df, it will return the total number for you. All right. So if I click on a new year and top year, it will just return that new, like a new table I just created for me. So that means we're no longer using df. We can now use the top year to access our table. So that df we've been using just like a table name. Okay, so let's look at this. If you have something like this, df, then the name of the column, Fiona, then this is just like if your column has no values, like blanks, so you fill them with those null values with 10. That is what this means. So you can put anything here, you can fill them with anything. So that's what it means. So for tonight, the last thing I'm going to do with us is this one. df, let's say df dot pop. This is used to delete a column. Okay, let's do df. This is our movie. We have title here, runtime. Okay, let me delete the director column. I will just put here director and I will run. So if you check, the director is gone. We no longer have director column here. So I can still delete. Let me delete this feedback that I added. So you just put the column. You use pop. So we used this pop earlier in the class, right? When we were doing data types like lists and dictionaries and so we use the pop. So like I say, we're learning all those things because you will need them. So if I do df now, the feedback run an error. I think this should start with capital letter. Okay, so it's case sensitive. So you can see now no longer have feedback. So to delete column, so that is how you do it. So guys, that's where we will end the class for tonight. This is Pandas part 1. And next class we look at Pandas part 2. In fact, with this you have done almost the major things in Pandas. So I want us to take this. So if you have any question, it's time to ask. Please ask your question if you have any question. I've recorded the class. The video will be available. So when you get the video, take your time to go through it. So if you have any question, please ask. Then you use the conditions, which is very hard. You remember when we were doing power query, we did something like that. When we added a new column, we populate it with the same value that we added a column company, then just. So if you are going to do it that way, that is a very advanced functions. So you are going to use a very advanced function, which I won't do now. I'm not even. So that is advanced, something very tricky. Mostly you're not likely to come across something like that. But if you're adding a column in this way, just like we did in power query, it's just the one that has one values, just populate it with one values. For your data, when you are entering your data, you are supposed, if you have specification like this one supposed to be good, very good, all those things should have been done when the data was being imputed right from the beginning. So to add a new column is always much easier when you just have to populate it with one value. Except in a condition like this, there's something I did which I skip it. I didn't want to bring it. So like something like this, I'm coming. So something like this. This is me adding a new column, but with a condition. The new column name is new balance equals to df. I have a column known as balance in this table. I have a column known as balance, but I'm giving a condition that each value 1000 should be added to it. So now you can see now all the values now will now have 1000 added to them. Where is that thing? So all the values will now have 1000 added to them. So when I strike this, you can see this one was just 00, it now has 1000. This one was 83. So all these values have added 1000 to them. I use it to create a new column. This is a column with conditional column. I create it with conditions. When we're doing power query editor, we're learning it. We created a conditional column. So this is a conditional column. I said that all the values here, I want to add 1000 to them. I'm creating a new column that will return this balance with 1000 added to all the values. So I create it with condition. So we are talking about creating a conditional columns. So that is how to do it. You define your conditions and it create it for you. But we just want to create a column that you just populate is the same value. So that is how to go about it. Is that understood? Any other question? Any other question? So just have to learn. You have to practice, practice, practice. You see this one now, I didn't do this because I assume when you practice you come across something like this, you think wild. Then when you think wild, you find a way to figure out some things. But just that question that brought me back to this, I skip it intentionally. But just that question you asked, I did not even want to do it, but I just feel like let me just do it. Then I had to go and bring this, how to create a column with conditions. So I've taught you, you can think wild. I've shown you some AI tools you can always use. So go there and ask AI, what if I want to create a column in Python with, you define it, AI will be, okay, this is how to create a column in a new column in Python in Pandas populated with the same value. But what if I want to create it with let's say I have very good, so what will I do? AI will write it for you. So you are in the world of AI, it's easier to learn now. So it will, so that is how to think wild. That's why I intentionally skip this. Just that question that brought it back and made me to just look at it. I didn't want to do it. I wanted that one to be you thinking wild. So it all boils down to practice, practice, think wild, use AI to learn too. So any other question? Okay, in the absence of question, that is the end of Pandas part 1. So in our next class we'll look at Pandas part 2, then move to Matplotlib and so on.